Hello JavaScript folks. We're on chapter 10. We're going to do a validation application that uses JavaScript on page 297. That one is, there's a lot of parts to it which are not extremely well explained in the book, so we'll just go ahead and do it here. First, let's take a look at the HTML. And let's see. The form is going to go to register HTML, which is another file we're going to look at. And the name of this form is member form. Interestingly, they have field sets. This is a little bit different for us. A field set which looks like this. It creates this this border around sections, and the legend is what appears in blue here because of CSS, of course. Don't forget to use these labels. Label for email, and then you got input type text with ID and name email. Something new here also is a placeholder, which gives you an opportunity to write something in the field which will disappear after you start typing, looking like that, at least 6 characters. We have an input of type password and a second one that's called password, and the other one, which is also called password, is called verify. And I don't think there's anything else different here, so let's go on to JavaScript. So now in the document ready function, we're going to place our span elements with the star after these elements. First we can call all the input elements of type text with this selector, and since password element is not considered of text, we can just use the ID for the password element and the verify element as we've seen in the HTML. And by the way, we could also use the selector password. And so I'm going to save this and we're going to try it out, and we have stars after all the fields. That works. If we had, just to show you, if we use the input selector, it would not work very well because it would those are also viewed as input elements, submit and reset, and those now have a star next to it. So this is why we're better off using what the book suggests. And then we move the focus to the first field with this command. Now they're going to make a date. So we have an object, a date, that is now in variable today. We can use now the object today and get the month, which is going to give us a month starting at 0, so we add a 1. And now our month is containing the digits. Today, get date, it would be nice if it was get day, but get date actually gives you a day. Today gets full year, and now we get to see this interesting if statement. Well, I don't think we covered that, but you see a question mark here and a colon. So this is the old way of an if statement from the C language. And what we're saying here, the first, on the left side of the question mark is the condition. Is month smaller than 10? If so, we need to put a 0 in front of it. We type a 0 plus concatenate the month. So if it was month 8, then we put 0 and put an 8 next to it. After the colon, this is in case the month is not less than 10. Therefore, we just put out the month itself. And now we concatenate slash, and we're done with the month. Then we're going to pad the day, and if the day is less than 10, same thing. Yes, true. It means we're going to put a 0 and concatenate the day. If it's false because of the colon, we just going to print the date and concatenate the forward slash. And finally, we can concatenate the entire year, since we used a full year, which gives us 4 digits. And now the start date field is populated with date text, which we just have taken care of right here. So now we create the code when the form itself, member form, is being submitted, and the event which we can use this variable down here when we use the prevent default, event prevent default. That's the only place we'll use this variable. And we begin with is valid true. And along the way, if anything is false, then it will not go through. First, interestingly, we have a regular expression here, which we're going to put into a variable called email pattern, which we can, of course, call anything. And we're also going to save email from the email element with an ID email and its value. First, we do the email. If it's blank, then we're going to, following the email element, we're going to fill in the text with this field is required, as we've done before, and of course its value equals false. Now we use this pattern, and let's take a look at this pattern. This is regular expression, and I hope that you folks will be interested in following that further on your own, unfortunately, because we don't have time to look into that in detail. It takes a while. But this one is not too complicated. First, regular expressions are surrounded with forward slashes. There's one that starts and one at the end. Everything inside is considered a regular expression, which are characters which have special meanings, such as B with a backward slash in front. That is a regular expression command which is called a boundary character. That means if you're going from a space to some text, that's the boundary. It doesn't actually include the space or the character. It just tells the regular expression that we are now entering into text. So this means that the regular expression is going to start looking right at the very beginning. It has to find some letters. Now, we have square brackets here. Inside the square bracket are all the choices of different letters that would be allowed, character by character. So here we can have any uppercase letters, any lowercase letters, any numbers, a underscore, a percent sign, a plus or a minus. These are all characters which are allowed apparently in an email. Those are usually such as the percent is powered because these emails coming from a URL could contain these characters. We're going to see that later. So what this regular expression is saying, any of these characters are allowed, and following by a plus. This plus is a command in regular expression. It says one or more. Therefore, we can have one or more of any of these characters for an email until we find an @ sign. Once you see the @ sign, once again, we're going to have some kind of website, which is also going to be composed of uppercase, lowercase, and this time it looks like only dashes or periods, interestingly. And again, we have the plus that means one or more until we get to a period. But you notice that the period has a backward slash in front because period is also a reserved word in regular expression. It means 0 or more, so we don't want that meaning. We just want a period, so we protect it with a backslash. Following that period, of course, we're going to have either uppercase letters, lowercase letters for .com or .edu. And interestingly, in the braces, this is a range of numbers of these letters that precede. It looks like the .com could have between 2 and 4 characters. And again, nothing at the end. This is the end of our string, and we have a boundary at the end. So this is the regular expression which now is included in email pattern. Now over here, the way you use this is that you take your email pattern, you use the method test, and you provided the email itself, and it will come, if this particular pattern is matched very well in the email, it will come back true. This is why we have a not in front of it, an exclamation mark, and if it's not matched with the pattern, then we're going to give it the error message, which is going to appear in the next element after the email input element. There we go. And then of course you know that if everything works, then we're going to blank out that asterisk. Now we do the passwords. We take the value of the password, we see if it's blank, then we also have to check if the length of that password is less than 6, and then we look at the verify, and at some point you're going to compare the two. Else, if the ID verify, the value of it is not equal to the value of password, then we have problems. Now when you validate a name or just a plain string, what you can do is at least trim the blanks out of it, and we're going to do this with both first name and last name. Here's another regular expression, the zip pattern. So the zip pattern, here's another symbol which is similar to that boundary one. This one is a caret, and that means right at the very beginning what you want is a digit. D with the backward slash is looking for one digit. However, we have some braces with a 5. That means we want 5 digits. And that will be followed by a set of parentheses here which takes all this information. And within these parentheses, we have a dash, another digit, and 4 of those. So we can have the special zip code with an additional 4 digits followed by a dash. And after the parentheses there's a question mark, and the question mark stands for 0 or 1. So you could have 0 of those 4 digits or just one set of those 4 digits. And the dollar sign is the opposite of the caret. It means that you want nothing at the very end. So we have nothing in the very front, we have 5 digits and maybe a dash and 4 digits, and then nothing at the end. This is a pattern for a zip pattern, and we do the same thing. Zip pattern test zip, and if it's not true, we give it the error message. They don't give you a regular expression for the phone, but you're going to be doing that in the exercise, which is going to be fairly simple because I will give it to you. It's not that complicated anyway. So that's about it. Then you got your event prevent default. If is valid is false because you don't want it to go anywhere. Okay, now the register.html, which is going to display the data on the screen. Starting at the bottom, this is the short HTML, which is going to, there's a script down here, which is going to call the function display data. Display data is, excuse me, defined right here. Display data. Display data is going to call the decode, and the decode is defined above. Decode right here. And so let's start there. This one is also using a regular expression. This time it's the replace. It's exactly the same thing, except this time the regular expression is in the first argument, and after the comma we're going to replace by something. In this case it's going to be a space. So what we're looking at here is First of all the pluses that are going to come back from the URL, sometimes you notice there are pluses that replace the spaces. All the spaces with pluses are going to be replaced by a space, and the G at the end of a regular expression signifies globally. So it's going to go through the entire string and replace all the pluses by space. Then the other problem after coming back from URLs is that all the @ for instance, are going to be replaced with the %, and two hexadecimal characters, which can be lowercase a to f or uppercase a to f and then 0 to 9. So 0 to 9 is 10 digits plus 6 digits a, b, c, d, e, f. And there's going to be two of those, remember? And it's going to be done globally. So the text which is included in the parentheses of this function decode, of course, comes from here, where we're going to use decode, and we're going to pass the field part, the first element in the array, and then the second one. And so these are going to be strings. We're going to pass it to decode, and decode is going to clean up those strings of all the special characters which came back from the URL. Now we're not quite done. Now we are replacing, this is the regular expression, right, which recognizes these bad characters, and after the comma we want to replace it by a function, and the function of course is also going to use the same text which is now being looked at, and we're going to return a string. But let's start from this part. We're going to use the 0x. So what we have, remember, is %, 2 digits, right? Which is going to translate in programming language as a 0x, which stands for, from this website, writing a value with 0x before means it is written in hexadecimal notation. That's all. So if we have, for instance, 0xFE, that means the number 254. By the way, I want to show you these special characters in URL. I did submit the form, and after the question mark you can see email equals OND, and here's the @ %40, so that is an @. And also remember that we have ampersand, which are separating the fields, and we have equal signs which separate the value from the label. And then of course we have the question mark, which separates the URL from the data afterwards. So now we want to take that percent and 2 digits, and we want to turn that into the OX, concatenated the text of the substring 1 to 2. And why is that? It's because 0, which is just a %, we don't need that one. We just need the two numbers following. And we're going to put that through from car code, which is going to take that code and return it as a regular number. Now, in order to capture the label and the value to produce this form, we need the code from the display data function. Okay, so first we take the window location, which is a URL. We turn that into a string, and we split that string from the question mark, which should give us an array of 2 elements in URL parts. If we don't have 2 elements in this URL parts, then we have a problem because we don't have data at the end of the URL. Now we're going to take the second part of that of this array, because it's where the data is, and we're going to split all that by the & to separate all the fields into this array called fields. If the field length is equal to 0, it means we don't have any data. Otherwise we're fine. We can start making a table out of this, and we're going to do a for loop, and for every field which contains the label and the value in the array fields, we're going to split that data by the equal sign, which is going to give us another array of field parts. and you notice we're going one element at a time in fields. So now we should have two fields, the value on the label on the left side of the equal sign and the value on the right side of the equal sign. The one on the 0 is the label, and we decode that by passing it the field part 0, which is the label. And then same thing with the field part 1, which contains the data. We decode that to make sure there's no special characters, and we place that right back into itself. Now we can print them simply, print the label and print the data, just as it is now done here. Print the label, print the data, and so forth. So this is it. It's just a little complicated, but I hope this explains it fairly well, and the video is getting long, so we're going to quit right here. Thank you very much for listening, and good luck.